In 11.5, we're going to explore the definition of a function. Now, we defined it in 11.1, and what we said then is that every x only goes to one y. Goes to a single y value. In other words, every input only has a single output. Now, the outputs can repeat, but the input cannot. But let's read like the more formal definition. It says a function is a collection of ordered pairs, x comma y, such that any particular value of x is paired with at most only one value for y. So this is sort of what it's saying, right? That x is paired with one y. But it's leaving open the possibilities that some x's won't be paired with any y. And that's why it's phrased in this more formal way, so that x can either go to nothing or x goes to a single y value. The set of all x coordinates is called the domain, and the set of all y coordinates is the range. All right, and that goes along with what we hopefully already knew, but it's a good review. So let's try these. So this is a set of ordered pairs. And they don't use the word set, but collection is another word to say set. And set means curly brackets. Right? It is a collection or a list or a group. And when we have one of those, we use curly brackets. All right, so this is 4 different points in curly brackets. And we want to know, is this a function? So what we look for are, do the x's repeat? Is it possible for an x go to 2 different y's? And nope, the x's don't repeat, so it is a function. The domain are the x values, so we would just list the x values. And this one we're using a set for the domain because there's not infinitely many decimals between these points. It's just 4 different x values, so we list them with curly brackets. -2, -1, 0, and 4. It's a tough squeeze, so feel free to write it up here if you need to. Then the range would be the y values. So in this case, 3, 5, 7. And then if a y value repeats, we don't need to write it again. We just write it once. All right. So hopefully that goes along with, what we already knew about a function. We're just using more formal terminology up here now. All right, let's see why this one's not a function. Well, why it's not is because x equals 1 has 2 different outputs. Has 2 outputs. That is what makes it not a function. And also, x equals 3 has 2 outputs. And the rule is that every x only goes to one y. So that's why this is not a function. We can still list the inputs and outputs. So domain and range can still be in play. The x values are just 1 and 3 for this collection of points. And the y values are 2, -2, 9, and -9. So those are the y values for range. All right, so that's how to do these if it's just a set of points. Another version of a set of points, though, is a graph. So to determine if a graph is a function, one thing we can do visually is called the vertical line test. It says if any vertical line, so hopefully we remember vertical means straight up and down, passes through more than one point on the graph of a relation, then the relation is not a function. And relation, that's not been defined up here. Relation just means a set of points. It could be a function, it could not be a function. So all these we can call relations, but we don't know whether they're functions or not, at least not yet. So let's look at A and decide whether it's a function. So the rule is that each x goes to one y. So if we picked like x equals 1, oh, that's just 1 point. x equals 3, there's 1 point there. Now, remember the more formal phrasing said it's okay if some x's don't go to anything. But here, every x goes to 1y. The vertical line test says that if I crossed this graph with a vertical line anywhere, left to right, it would only go through the graph once. That's another way to visually see that it's a function. So yes, this is definitely a function. So let's try this one. So we got a vertical line and then a dot. That's our relationship, our set of points. But here, x equals -3 has lots of outputs. And it's only supposed to have 1 for it to be a function. So this is definitely not a function. And a vertical line, if we pick the vertical line that's here, it would cross at more than 1 point. That's what that vertical line test says, is any vertical line should only cross through once on a graph. Let's look at this one. I can draw the vertical line at the same place. This vertical line crosses 2 points. And that's another way to say that x equals -3 has 2 different outputs. Right? Those 2 points are the 2 different outputs, and that's why this is not a function. All right, last graph. I just pick a vertical line. I can't have it at -3 because there's no graph over there, but let's just I picked 2, but you could pick anywhere. What we're looking for is how many times does a vertical line cross? If a vertical line crosses 2 points or more than 2, it is not a function, because that means this x value has 2 different outputs. Okay, so hopefully that makes sense. That's how to do it graphically. Let's look at it from a table perspective. So if given a table for a relation, and remember relation just means set of points, we want to decide if this is a function. So what we do is just answer the question, does every x go to one y value only? Well, let's look. The other way to look at it is, do any of the x's repeat? No x repeats. So this is yes, it is a function. Exclamation point. So that all we're looking for is, does each x go to a different y? In other words, are the x's all unique in the list? All right, let's turn the page and look at this from equations, right? So we did a set of points, we did a graph, we did a table. The last way we might see a relation or a set of points is in an equation. So first example, x equals y squared. The real way to determine if an equation is a function is to see if we can solve for y. Because if we can get y equals and then a single function here, well, then that means that every time I plug in x, there's only one y. So if we can find a formula where we can plug in x and get one y value, then that makes it a function. So let's try this for x equals y squared. So I'm gonna, we can read this later, but let's just try it right here. X equals y squared. If I tried to solve for y, get y alone, I would need to square root both sides. Right? That's how to get y, undo squaring with square rooting. But the rule for square rooting both sides is that you have to put a plus or minus. So here I can get y equals, but it's two different formulas really. One a positive square root, one a negative square root. In other words, like let's look at it from this perspective where they try a number. So they tried x equals 9 in this equation. So 9 equals y squared. So does x equal 9 go to one output or more than one output? Well, what they did is square root both sides, and there's two different outputs for a single x value. And that means it's not a function. So that's the rule. If we put in a single x value and get two different y values, that is not a function. Let's see another one of these, because that's definitely a little weird, and one we're going to practice more with on the next page. Oh, and then they, sorry, skipped over the graph. They graphed it in Desmos, and we can see that if we put a vertical line here, it crosses through more than one point, right? And this is that vertical line at x equals 9, and there are two different y values, +3 or -3. All right, let's try another formula. So we have 4x squared minus 3y equals 6. We want to know, is that a function before we graph it, if we're just using the formula? So what we're going to do is algebra to get y equals. So all we're trying to do is solve for y to determine if that's a function. Get y alone. So the first step, I need to move the 4x squared to the other side. So we're going to subtract 4x squared, subtract 4x squared. So we get this. Still trying to get y by itself. So we would divide by -3, divide by -3. So this is what it's looking like. You could, I guess, we could distribute and divide both these pieces by -3. Yeah, maybe I'll do that. So 6 divided by -3 is -2. -4 divided by -3 is +4/3 x squared. So if this is what y equals, just put equals y, then any x value I plug in, I would get what y is. If I plugged in x equals 1, it would be -2 plus 4/3, that we could get a y value for that. If I plugged in x equals -1, it might be the same y value, but it would be only one output. So each x gives one output. And graphically, that means any vertical line would only cross this parabola once. So that means it is a function.